So I'm here in the motors lab. Here's the Squirrel-Cage induction motor. The lab asks us to examine the construction of the skim, paying particular attention to the motor, connection terminals, and the wiring. Okay, so this one you'll notice there's no rotor circuit shown on the faceplate at all. Just the stator windings connected to terminals 1 and 4, 2 and 5, 3 and 6. The ratings of those windings are 120 volts at 1.5 amps. You notice that the 120 volts is a phase voltage given there. The motor's ratings right here you see are 208 volts, 1.2 amps. And so the voltage given there, of course, is a line voltage. And the rated current that the motor should draw when it's delivering its quarter horsepower at 1670 revolutions per minute. And so the idea for this one is that, the one phase in the stator has a phase voltage rating and a current that's a bit above what you expect the motor to draw at its rated output. And so if I open the front of it, we can have a look at, here's the bearings and the pulley which support the belt, and in there you can see the stator winding, and you can see the rotor and the end ring and the fins on it that act as a fan. So here now we have then a motor that's been disassembled, and you can see that this is the Squirrel-Cage rotor, and you can see the end rings on it. You can see that the iron core is laminated, but you can't really see the conductors because they're just inside the surface of the steel here. And so it's the rotor. Here is the three-phase stator, and you can't really tell how many poles are in there. You can count the slots, and you can see where the wire goes into each slot, and you kind of got to follow the wiring from here through to these little white ones here that I refer to as lead-in wires, and you kind of got to go around there and count them and where they start and so on this periphery here to figure out how many poles are on that. Or you can go by the speed. 1670 tells you the sync speed is 1800, and therefore you know that it's probably from there a 4-pole motor. So now I'm going to wire up the Squirrel-Cage motor in the kit, the lab kit or the lab station, and you'll notice the first thing is I have the belt installed on the pulley in between the tensioner here and onto the dynamometer. This dynamometer got a yellow face, but it's the one that we use here, and the watt meter. And so you notice that the watt meter is plugged into the 24 volt low power source, and that the green light indicates that it's powered up and ready to use, just like in the simulation software. So now this dynamometer is a bit different, right, from the one in the software. It needs 120 volt AC supply. So you notice I've connected it to the power supply in terminals 1 and N. Okay, so now I'm going to connect the circuit from terminals 1, 2, and 3, the power supply, through the watt meter, the ammeters, and the voltmeter, like is shown in figure 8.1 of the lab. And I'll pause while I'm doing that. So now, according to figure 8.1, I have my terminals 1, 2, and 3 connected to the input of the side of the watt meter. The output side of the watt meter then goes down to my current meters, and my current meters then down to the motor. And you'll see I also have a voltmeter connected in there, and of course the dynamometer has been connected as well. So the circuit is relatively complicated. There's a lot of wires here too, as in the software, and you notice I'm using red and yellow cables. The connecting wires here are different colors, but the different colors represent different lengths. And so I got some short ones, they're yellow, some red ones, they're a bit longer. And so one of the things we point out is 4, 5, and 6 down here are just connected to each other, 4 to 5 and then 5 to 6. And what that does is puts one end of each of your windings in a common point, and that's your neutral. And so that motor is 3-phase Y connected, in other words. Now, as I turn the power supply on here, the motor should start immediately. Okay, now it seems like it's under a load, so I should turn it off, reduce the load on my dynamometer down to 0, and so I thought that's where it was. The knob is a bit offline there, but it needs to be adjusted. And so now I'll turn the motor on with no load on it. That's what we should do. And it starts to move immediately. And so you'll notice the voltage here on the 250 scale is about 210. We've got some current on each phase. On the 2.5 scale, we are on the ammeter. So we got about an amp there, right? About 1 amp. A bit less. So it's making some noise. That's those tensioner bearings down there. Now, look at our wattmeter. And so you don't see this in the simulation software, but the wattmeter, it's a 2 wattmeter method for measuring 3-phase power. And you see this one has a reverse deflection, this one has a positive deflection. And so there's a switch on these things, there's a polarity on these things, and that one is positive. And if I switch the polarity here, you'll notice that that's gone back now to a positive deflection, but the switch is in a negative position. And so what that means there is that we have about negative between 40 and 45 watts on that side. We have positive about 125 on that side. So that gives us actually about W1 plus W2 gives us approximately 80 watts. And that's what the motor is drawn now under no load. And you see the 3 ammeters here, we look at that one again, that one's almost up to an amp, probably 0.95. This one here is a little bit less, closer to 0.9. And this one here, you see, is almost down to 0.8. And so I don't know if those ammeters got a 0 adjust here. I don't know if that one needs to be adjusted, but they should be a bit closer to 0.8 in my mind, with no load on the motor. And so now, one of the things, we can turn the load up. And on this dynamometer, so you measure the load in there. And so if I turn it up to 3 inch-pounds of force, okay, so I'm up to 4. Let's turn it up to 6. Okay, so we got it on 6 there, around 6 there. And so now you notice the current has gone up. And so I got a current of about 1.2 amps in that phase. And I got about 1.2 amps in that phase. And this one here shows just an amp, just a bit more than an amp. Now my wattmeter, look at my wattmeters. This one's gone back negative. And so that indicates that in addition to an increase in current, see now this wattmeter has, both of these wattmeters now have positive deflections. And so my total power into the motor is now 35 plus, call that 200. So that's 235 watts now. And so that, you know, that would be, you see our voltage here still at about 210 or a shade more. And so that would be the numbers you could put in your table at 6 inch-pounds of force. But really what I want you to do for this is to get your numbers out of the simulation software and fill your table up with those, okay?